Hi everyone, welcome to lab exercise 5.1 where we will be learning about viruses and prokaryotes. So if we recall the lecture, we learned about different types of viruses and bacteria that can be pathogenic. Not all viruses or bacteria are pathogenic, but some can cause disease. So in this part of the lab, what we're going to do is we are going to do a bacterial culture. What the students are encouraged to do is go around the building and swab different surfaces that they feel might have bacterial growth. Then we are going to put that culture aside and make some predictions. So step one, prepare the workstation. We're going to set up the workstation with our materials, which I have done already here. Our materials today are going to be this nutrient agar plate. It has some condensation, so we usually keep it upside down. But what this is a thin layer of a jelly-like substance called agar. Inside of that agar is nutrient media, usually bone broth, that the bacteria can use and eat. So if we swab a surface and then transfer that swab to this media, it should grow a culture within 1 week. So this is the first thing that we're going to do. We need to make sure to use sterile techniques. I'm wearing gloves, we have our swabs, and our undisturbed dish. Now notice that I'm opening it upside down. We don't want any stray fungus or mold to fall from the ceiling onto our dish. So again, we're going to keep it upside down. The first thing that I'm going to do is swab my keys here. When I am using my swab to test for bacteria on my keys, I am just going to kind of gently rub the swab all over the surface of the keys, getting in all the cracks and crevices and kind of turning the swab while I go. I want to get as much gunk and bacteria off of this lanyard as I can. I don't really wash these, so maybe this will be a learning experience and I will learn that I need to wash my keys. When I'm ready to swab my agar, I'm going to lift it and just barely open it because I don't want any contaminants falling into the agar. So I'm going to open it like this and then just barely touch the surface of the agar. I don't want to scrape across the agar. I'm just kind of gently rubbing it or tapping it on the agar. And hopefully we will see some results next week. Now this is trash and I can throw this away, and this needs to be labeled. When labeling my Petri dish of agar, what I'm going to do is, using a Sharpie, I'm going to write what I have tested. So I've tested my keys, and I'm going to do that on the bottom of the plate. The reason I'm doing that on the bottom of the plate is because next week when we come back, we're going to be utilizing the top of the plate to count colonies. So we want to measure the bottom of our plate, and then we're going to tape our plate so that the lid won't come off of the plate. So we just take the tape, wrap it around, and now it's nice and secure. I can write my name on the top as well as my class period. So if my class is 1EH, I can write 1EH. Now I'm going to set this aside, and in 1 week we can come back and check on our results. Next, we're going to make a prediction, and our prediction is, what do we think is going to happen to our Petri dish? So many of the students, they tested things like door handles or the water fountain, but the #1 prediction is that the bathroom, in some capacity, sometimes the toilet seat, sometimes the sink, depending on the classroom. A lot of people think we're going to see a lot of results on our bathroom. So let's see if that's true, because next week we are going to do the observation and analysis. And then we can turn the page. On this page, we are going to simulate the spread of a viral infection. And we're going to do this by exchanging bodily fluids. Now, normally I would have students walk around the room and casually exchange fluids with each other. Since we're online, we're just going to look at the process. So this test tube represents me and my bodily fluid, and this represents 3 people that I'm going to have a casual conversation with. What I'm going to do is I'm going to casually just exchange fluids with person number 1, and person number 1 is going to exchange fluids with me. Now I'm going to exchange fluids with person number 2, and person number 2 is going to exchange fluids with me. Last, I'm going to exchange fluids with person number 3, and person number 3 is going to exchange fluids with me. Now, in the next step, we are going to use an indicator to test whether test for the presence of this unknown virus. So I have my testing fluid, and it looks like I tested positive for this viral disease. It looks like person number 2 did not test positive. They are negative. They do not have the disease, or they don't have the virus. Person number 3 tested positive for the virus, and person number 3 tested positive for the virus. Sorry, person number 2 tested positive for the virus, and person number 3 tested positive for the virus. So this gives me a lot of good information. I know that the first person I exchanged fluids with does not carry the virus, so I could not have gotten it from them. But the second person does have the virus. I am going to assume that I got the virus from the second person, and then I may have transferred it to the third person. So this is called contact tracing. And what I tell my students to do is to record whether they were positive, and then the people that they exchanged fluids with. Person number 1 was negative, person number 2 was positive, and person number 3 was positive. Now, in this small simulation, it's pretty obvious that person number 2 is patient 0. But in an entire classroom, or even in the whole country, contact tracing can get very complicated. Normally, an interviewer will call people who tested positive for this disease and ask, who have you recently had contact with? In this way, we can track and possibly slow down the spread of disease. So turning the page, it gives us a little bit more information about contact tracing and kind of how contact tracing works. If I know that these people tested positive for the disease, these people did not test positive for the disease, then it's pretty apparent that this person must be patient 0. This is how contact tracing works. In fact, we experienced some contact tracing a few years ago when COVID first happened. So question number 1 says, who was patient 0, and were we correct? Well, we think that patient 0 was actually person number 2 because person number 2 and 3 both tested positive, but person number 1 did not. If I was patient 0, then all 3 of these vials would be pink, but only 2 of them are pink, so we can kind of assume that it's number 2. We will never know for sure who gave it to whom if these 2 exchange. But since number 1 was negative, then we can safely assume it was not them. So we know that person number 2 was patient 0. Based on this simulation, what is the mode of transmission of this mystery virus? Since we are exchanging bodily fluids, that means this is most likely an STD, or a sexually transmitted infection, an STI. That's not the only kind of fluid transmission though. We also have bloodborne diseases, so exchanging blood products or accidentally getting bodily fluid into a cut can cause this virus. And also exchanging fluids such as kissing. Kissing can also spread a disease through bodily fluids, but some are easier to spread than others, such as a droplet infection like COVID-19. The only thing you have to do is talk to someone, because when you're talking to someone, you are spitting on them and they are spitting on you. So you are exchanging droplets. Bodily fluid is a little bit harder. you really have to exchange a bodily fluid such as blood or sexual transmission. Now, what challenges did we face during contact tracing? Let's skip this one and go straight to, based on this mode of transmission, what measures can be taken? I want you to think of this question as if you are a public health official. If you are a public health official, you can do several things to slow the transmission of this disease, such as contact tracing, but also public education. Maybe they don't know about this disease and they're passing it around without knowing it. Also, frequent testing or low-cost testing. That also goes hand in hand with public education. So we want to test frequently. And any preventative measures such as wearing a mask for a droplet disease or even wearing a condom for a sexually transmitted disease. So those are all great preventative measures. Now, what challenges might public health officials face? Well, there are many challenges that public health officials might face when they're trying to track down all of these people. They may find that it's hard to get some of these people on the phone. They may also find that some of these people are not willing to share their personal information. So those are some hurdles that contact tracing can encounter. And we countered those concerns with public education. So the answer to number 5 goes back into question number 4. Question number 6 is very important. Would antibiotics help to prevent this disease? It would not, because we already said that it's a virus. Viruses are not treated with antibiotics. Only bacterial pathogens can be treated with antibiotics. This week was a little bit of a short lab. Thank you for joining me, and I hope to see you again next week.